So we're just doing a quick walkthrough of the proof of concept site that we've got here in Dubai, and the project is a 4-panel 320 watt NOR PV panels with a Neon Energy solar PVT thermal collector, which has been mounted on the rear of a standard NOR 340 watt panel. Yeah, so as you can see, it's just a rooftop mounted system, just sitting in the area where the AC units are fitted. And the panels, like I mentioned, are just standard, what are they, 1.6 by 1 meter panels. And what we're doing here is we're monitoring the thermal energy using delta T, so temperature differential of the incoming water supply and the outgoing. So you can see the two platinum resistance temperature sensors here, red and blue coded, which is just showing the in-feed and the outtake water temperature. The panels are connected thermally in series, so they've just one feeds the other. You can see these the water connection loop here, and then the just simple evaluation system. We've just got about 5 liters per minute coming up this supply, and there's a flow meter here which is giving us our flow rate, and the simple calculation, which is delta T by flow rate, and a constant gives us our kilowatts per hour, and also instantaneous kilowatts. The data is being logged here in a defined instruments data logger, which is connected to a cloud host, so we've got remote access to the data. And underneath the system here, we've got our ambient temperature humidity, which is just a little integrated sensor, which is connected directly to the data logger. Yeah, so it's a really simple installation. The energy is actually going straight down to the swimming pool. So using the swimming pool is a pretty much an infinite heat sink. Here you see off the just off the balcony, we've got the pool, and then there's just underneath that shade is the filter surfaces. It's a little booster pump, lift the water up to 7 meters up to the roof here, and that, like I said earlier, is giving us our 4 or so liters a minute, which is how we're getting that thermal. So now I'll just run you through the energy that we're getting off these panels right now. We're just coming into the first week of February here in Dubai, which is the coldest month of the year, and we're still getting some pretty good results. So what we have here is the Defined Instruments cloud console interface for the monitoring the data that's coming off the data logger that you saw in the roof installation. So what's happening is the data from the PV array and from the thermal output of the panel is being recorded in that Defined Instruments data logger, and then it's being sent off to AWS Cloud Services, and here you see that visualized. So what we're looking at is the surface temperature of the PV panels. There's a sensor right in the center on the frame of where the 4 panels come together, and you see that as the blue trace. But as we add current trace on, so now we're looking at the current that the 4 modules are producing in 4 panels are producing in series. We're getting about 7.5 amps peak midday off those panels, and you can see we've got about 120 volts coming from those panels. So altogether around about peak power 780-ish watts. So now if we look at the thermal performance of the panels, and the 2 traces we're interested in here are the green and the lower red. And what we're interested in is the difference between the temperature of the water going into the panels and what's coming out, which is around about 7 or so degrees of difference at a flow rate of around about 4.5 liters per minute. So this is on a relatively cloudless day, a little bit windy, and it's what's causing the noise on that thermal trace. But if you come across to a cloudy day, and you'll see the story is quite different. Now we're getting interruption to the solar PV, and you're also seeing effects on the thermal as well, as the combination of the cloud and windy conditions are cooling the surface of the panel. It's affecting both our PV production from the clouds, but also the thermal production from a combination of the wind cooling the surface of the panel and the cloud cover coming across as well, which means there's less thermal energy, infrared engine energy being available for heating. So that's what we have, looking at sort of 2 days, 3 days of data, and you see every day same story, but just obviously different conditions. We can see that data as a graphic representation, or we can see it in tabular view. Well, it's nighttime when I'm recording this, and you can see there's no PV. But if I go back to midday, and this is what I was talking about earlier on, around about 120 volts, and we're close to 7.5, 7.75 amps, which gives us corresponding 740 watts off those panels. And you can see over here the delta T is around about 7 or so degrees of temperature rise across the panels. The blue trace is the energy that the PV modules are producing in kilowatts, peaking, as I mentioned earlier on, at around about 750 watts. Then the red trace, that center trace, orange red, we're getting around about 2 kilowatts of thermal energy off exactly the same solar panels. And if you combine those two, we're generating around about 2.75 kilowatts peak off those 4 panels, which is significant considering the 340 watt peak panels. So putting that all together for daily production, right now, which is in the coolest winter month, as I mentioned, we're getting about 5.8 kilowatts of PV, kilowatt hours of PV for the day. Thermal power is roughly double that, 10.88, and the total power of this 4-panel array is 16.72 kilowatt hours for the day. And that's the first week of February.